Good morning, everybody. Good morning, Mohammed and everybody. Can you guys hear me now? Good, good. I'm trying to synchronize my tablet to my laptop so that I can able to write and explaining you about tomorrow's questions. What do they look like? I can give you a good picture on it if you give me just a second. I'm just configuring the tablet right now and able to write and explaining just like we are in the classroom. I just need. Okay, while it starts to connecting, it just takes a little bit time to connect, but I have a good idea as what would be the exam looks like. Particularly, the exam would be what you have on the review guideline. I'm just focusing on points that are highlighted on the review guideline. So I can tell you what type of questions should we expect or you would expect tomorrow. Okay. Um, you can, I'm assuming that you all have your review guideline in front of you, or you can able to print out at some point, or you'll have a slide of that. Um, so okay, it's just preparing meeting. I don't know what happened here. Okay, so the type of questions that you'd expect, for example, I would ask you. I hope it's good now. If you can take notes, so that it will be very helpful. You guys can hear me? Can you
Yeah,
guys?
I can hear you, Professor.
Okay, wonderful. Okay. Just trying to synchronizing my tablet here. So I would ask you a question. Just we can discuss. Okay, you can ask me. I'll ask you. We can discuss. You can take notes. Later on, I can able to upload this on a video and then send that to you. So the first question that are you recording the meeting? Yes, Mohammed. I'm going to record this. Pray for me that I can upload this on my YouTube. I don't know. Sometimes I'm having hard time. I'm using the archive internet. It's a free archive internet page. You just have to donate to them. You don't have to pay. Lately, they have some issues with the archive, but I think it works for my 1 or 2 class. So I definitely will send that to you. In the meantime, also, Mohammed, that the videos that I posted earlier is also a duplication of this. It is the content of the question. Trust me, they are the same, but I'm going to upload this as well. The only problem I have here is that still the tablet is trying to connect with the laptop. It's not connecting as of now, but I can talk anyway. So if I ask you a question, which of the groups of elements had the most negative electron affinity? Which of the groups of elements have the most negative electron affinity? And if I ask you, if I give you a choice, alkali metals, group 6 elements, noble gases, and halogens, what do you think would be the answer? Which of these 3 or 4 groups would have a most negative electron affinities? In other words, a most negative electron affinities means that a highly electron negative groups. So I would have for you, like I say, alkali metals, noble gases, group 6 elements or halogens, or group 7 element halogens. If you have those 4 choices, what will be the best choice that you think will be the answer?
Would it be
I'm sorry. Hello.
yeah, I said alkaline metals?
No. The opposite. The opposite. The most negative electron affinities means that the highest electronegative groups are the one located on the right, which is in non-metal side. Metals have highly positively charged affinities compared to non-metals. Non-metals try to have a predictable when you take this exam. So the pattern or the way that it shows you, the more you go to the right, the more it is highly negatively, they are negative, highly negatively charged, or they have high electronegativity, I would say. So if I have group 6 versus group 7 is the right of group 6. So group 7 has a high electronegativity than group 6. Okay, so alkali metals is group 1, halogens is group 7, um, halcogens or oxygen group, it's group 6. So if you compare these 3, the halogens would be the highest electronegative elements are assigned there in that group, because it is on the right. But having said that, if you take noble gases are the one on the far right, which are group 8. They are not highly negatively electron affiliated, or they are neutral, I would say, because their outermost shell is already filled. So noble gases will be out of the picture in this case. If any question you have on this one, you can ask me questions. Still, I cannot synchronize this. Okay. Okay. There will be a question about electrolytes or non-electrolytes. Okay. Electrolytes means that you can see the notes on chapter 4 actually. Electrolytes are substances that that can able to conduct electricity, that can able to dissociate into ions. These are called electrolytes. So mostly ionic compounds are electrolytes. Okay. Um, Please don't be tricked that if a substance dissolves in water doesn't necessarily mean it's an electrolyte. Okay. I can give you an example. Say for example you have salt, sodium chloride, versus sugar or glucose, which is um, C6H12O6, right? Now, which of the two would be an electrolyte, sugar or sodium chloride? What do you think and why? Anyone can answer. This is a free discussion. You can just jump to the mic, you can answer. I still have problem to synchronize my tablet. I wish I can synchronize my tablet so I can able to take to write notes so that you can take notes too. So is sugar is electrolyte or not? Sugar has sodium chloride. Thank you very much. I see that. That's Mohammed. Thank you, Mohammed. Sodium chloride is an electrolyte because it is an ionic compound. It's an ionic compound. When it dissolves in water, it definitely dissociates into ions. But sugar, on the other hand, dissolves in water. However, it doesn't form ions. Okay, so don't be tricked that not all substances dissolves in water doesn't necessarily be an electrolyte. Uh, in the meantime, I also like to add here gases like carbon dioxide or nitrogen dioxide, gases, covalent compounds, they cannot be electrolytes, okay, because they do not form ions. That's the whole idea or the whole secret is that gases or covalent compounds would not be an electrolyte because they don't form ions, okay. So about solubility, there is a solubility guideline. I posted that for you on the review guideline. I remember that it's in a blue color. You can use the solubility guideline as the guidance for the exam. So the solubility guideline would be helpful. If you don't know how to read the solubility guideline, I can able to explain that. I'm sure that there is an experiment regarding the solubility guideline. You guys have done experiment 10 or 9, I don't remember now since I didn't teach labs this summer. Um, so the solubility guideline tells you which of the compounds can be soluble or insoluble, okay. For example, you may have nitrates ion. Nitrates, if you have nitrates, always nitrates are compatible with water. They are they are called hygroscopic. They are called water affiliated. They can easily be dissolved in water. Even if you have heavy elements or heavy metals, when there is nitrates or acetates, they can be always soluble in water. Okay, so if I give you a choice, silver nitrates, sodium nitrate, which of the two can be soluble? Silver nitrate or sodium nitrate? Which of the two can be soluble in water and which of them are not soluble in water? What would be your suggestion or your answer? Obviously, any substance, regardless, that has nitrate ion, NO3, nitrate ion is always would be soluble in water, okay? How do I know that? Just look on the solubility guideline, which I gave you, so that you can able to read from that, okay? You don't have to memorize this. The solubility guideline experimentally determined or experimentally known. I don't even know from the top of my head, but by looking up that chart, I can tell which substance will be soluble and which substance is not soluble. Um, for example, something like silver chloride, right? Or sodium silver chloride, or like lead chloride, silver, lead, mercury. These are heavy metals. Sometimes they are not easily be soluble in water. Okay, you have to be very careful when you look up silver or lead or mercury, that they are not environmentally friendly, by the way. So if these compounds are soluble, if these compounds are combined with halogen family, they will not be soluble in water. Again, you can verify that from the solubility guideline, like I say. However, if silver or mercury or lead would be mixed with a nitrate ion or acetate ion, they can be soluble in water, because nitrate and acetate are the one who really plays a role here for the solubility, solubility of compounds. So solubility guideline would be very helpful for this question. I mean, for the exam tomorrow, please make sure that you have solubility guideline in front of you. So you can use that, of course. So, for example, about strong electrolyte and weak electrolyte, we said that electrolytes are the one who are dissolved in water and form. I mean, they can generate ions, and that way they can able to carry electric current. That's what electrolytes is about. Now, we have to identify strong versus weak electrolytes. Okay, strong electrolytes are always associated with strong acids and strong bases. So if you know strong acids and strong bases, you know strong electrolytes. It's simple as that, okay? So you have to study what's an acid. Okay, you have to study what's a base. Okay, so an acid is a substance that always carry hydrogen ion in a solution. That's one definition. A base or alkaline substance. Okay, now I can able to join. Oh, hallelujah. Let me see. I think I can able to join. If I can able to join, I can able to write. So I don't have to talk too much. Let me see. I think I'm joining. So a base is a substance that has hydroxide ion or OH ion in a solution. Okay. Now we know what's an acid and what's an a base. Okay. You have to make a picture, acid and a base. Now, once you know what's an acid and a base, the other things that you should know that how do we identify a strong acid from weak acid? How do we identify a strong base from weak base? Okay, that's another thing that we also have to pay attention. Okay. Yeah. Okay. I think I got it now. Let me see. Please. Okay. Let me see. Do you see the sharing? Let me create a slide here. If you can see what I'm writing, then we are good. Okay, let me write something here. Please let me know if you see it. Strong acids.
Yeah, I can see it.
You see it? Thank you. Okay, acids of halogen families. Okay, these are strong acids. Okay, so if you have hydrochloric acid, if you have hydrobromic acid, if you have perchloric acid, anything associated with halogen family, hydroiodic acid, but unfortunately, HF, okay, it's an exception. It's not strong acid, okay? Nitric acid, sulfuric acid, these are strong acids. There is an exception here. If you ask me why, I do not have an answer for that. Unfortunately, hydrogen fluoride will not be dissociated completely in water like others halogen family. All these are strong acids, okay? So by implication, if they are strong acids, they are strong electrolytes at the same time. Okay, they are strong electrolytes. This is how you define. And bases, when we come bases or alkaline solution, right? So the bases or alkaline solution are substances that have hydroxide ions in them, OH ions in them. So alkali metal hydroxides in general, okay? Alkali metal hydroxides, I would say XOH, where X refers to any of the elements. It can be sodium, it can be potassium, it can be rubidium, it can be, you name it, CCM, all group 1 element. They are strong bases, okay? They are strong bases. Strong bases, by default, they are also strong electrolytes, you see? So it's like you are killing two birds in one stone. If you know strong bases, you know strong electrolytes. If you know strong acids, strong electrolytes at the same time. Okay, so like the question we have, I will give you. Okay, I put CuOH2 versus KOH. Which one is a strong? Which one is a base? Which one is a base out of the two, and which one is a strong base? Here, I hope you see it. Let me just make a red color here. Which one is a base out of these two, and which one is a strong base? And by default, which one is a strong electrolyte? If you made a mistake, don't worry about it. What's that?
KOH is a strong base and strong electrolytes.
Oh, okay. Who's that? Who's that? I just want to. Is that Cotman? Is that Cotman? Okay. Yes. I agree with you. Yes. KOH is a strong base and a strong electrolyte. Okay. Now, Cotman, how did Cotman knows that? Because K, which is potassium, is a part of alkali metals. Now, CuOH2, it's also a base, by the way. Both of them are bases. Now, Cu is copper, right? Copper, where do you find copper? Copper is not in group 1 or neither in group 2, right? Copper is alkali. No, it's a transition metal. So it's not group 1, it's not group 2. Then this is a base, but this is going to be a weak base. Okay, this is going to be a weak base, but this one is a strong base. Okay, does that make sense, everybody? So that's how you identify. Now, acids, we know what strong acids are, and by default, they are strong electrolytes. Now, carbonic acids like H2CO3, like organic acids, all organic acids that have carbon and hydrogen, vinegar, for example, a main component of vinegar is acetic acid. All these are acids, and then phosphoric acid. Okay, I can tell you that these are a good example of weak acids. Weak acids, and by default, they are also weak electrolytes. Weak electrolytes. Also, you can add to the list of weak acids the derivatives of strong acids. For example, nitric acid is strong acid, sulfuric acid is strong acid. The derivatives of those means that you remove the oxygen. The more you remove the oxygen from strong acids, they're getting weaker and weaker. Okay, for example, I have HNO3, which is a strong acid, which is a nitric acid. But if I remove one oxygen, which becomes HNO2. Now, this guy is a derivative of HNO3. However, HNO2 is a weak one, but this one is a strong one. Nitrous acid versus nitric acid. Sulfuric acid, which is strong acid, and if you remove one oxygen, you ended up with H2SO3. So this is a strong acid. Its derivative is going to be weak acid. Okay, so these are also be categorized strong versus weak. Okay, so if they are weak acid, basically they are weak electrolytes. So it's good to know strong versus weak. I have all this listed. I have all this listed on the review guideline. I'm not, trust me, you will not get any single question which is out of the review guideline, because I have both of them right now. I have the question, I already made the questions, and I have the review guideline here too. So I'm just reading the question. Well, in a different format, actually. I'm just instead of KOH, okay, I may say NaOH. All right. KOH, I say KOH is strong electrolyte, and why not? Sodium hydroxide NaOH is also strong electrolyte, because the reason why is both of them, the Sodium, also potassium, are group of alkali metals, right? And then the other question that you'll have is that a monoprotic, a diprotic, a polyprotic acids, that's also in the review guideline. If you have an acid like HCl, okay, or HNO3, these are called a monoprotic acid. Monoprotic acid because they have only one hydrogen ion in them. You have a diprotic acid, something like H2SO4 or H2CO3, which is carbonic acid or sulfuric acid. These are called a diprotic acid. A diprotic acid because you have two hydrogen ions, that's all. If you have two, it's di. A polyprotic acid is an acid that have a hydrogen ion greater than two. Okay, so I can give you phosphoric acid, for example. Okay, it's 3PO4. Now this is considered as a polyprotic acid since it has three hydrogen ions in it. Okay, so a monoprotic, a diprotic, triprotic, or polyprotic, all are coming due to the fact that they have the number of hydrogen ions. Okay, so please be careful on that. All of them are acids, of course, because they have hydrogen ion. Um, by the way, this is the definition of there are two definitions, Brown and Lemay and Arrhenius definition. Also, you need to know the Arrhenius definition versus Brown Lemay definition. Brown Lemay? What was that? Is that Brown Lemay or Brown Lemay the book, right? Uh, can anybody remembers me the other definition of acid and base? Bronsted-Lowry. I'm sorry, Bronsted-Lowry. I was talking about not Brown, Bronsted-Lowry. Give me a second. Let me just Bronsted-Lowry. This is also in the notes that I have in chapter 4, I believe. There is two definitions of acids. Okay, Arrhenius definition versus Bronsted-Lowry definition. Okay, uh, try to look on that. Uh, Try to look on that. So they have two different perspective of definitions, but I'll come to that point later on. Bronsted-Lowry definition of acids is differ and very wide it's very extensive compared to Arrhenius definition. Arrhenius definition is very limited and it's focusing with the aqueous solutions that dissolves in water. But Bronsted-Lowry definition is very broad actually in concept of defining acids and bases. Um, okay, so I don't want to jump here and there. Let me just go step by step here. But we definitely need to know. Hi, Comfort. How are you? I got your text. Hi. Yeah, we need to go step by step here, and yeah. Okay. The other thing we also need to know about how to calculate molarity. Okay, how to calculate molarity. Remember the definition of molarity. Molarity is moles of a solute, okay, divided by volume of solution. That's the definition of molarity, okay? So moles of a solute would be N divided by V. So molarity is simply summarized as N over V, okay? N over V.